Thank you, everyone. So my name is Guillaume Valadon. I'm a security researcher at Git Guardian. And today I will present my work, the work that we did on Docker image scanning, and more specifically, the work that we did on scanning 15 million images in DockerHub. So part of what we do as security researchers is to try to think as attackers. And we are lucky because in the security world, we have several frameworks that are defining attack path, and one of them is the one from MITRE. So today, what we'll do, we'll look at container registries, more specifically Docker registries and DockerHub. So in that case, attackers, they start to look for valid accounts. For DockerHub, it could be valid accounts, but what we'll do today, we'll use a default account. So if you have a default account, basically there is no authentication, no user and password. You just get a token, and the token will be able to give you the opportunity to talk to the API. With that in mind, you can attackers will start discovering containers. So basically, in that case, DockerHub images, and then they will scan these images for unsecure credentials. So that's the first step of what attacker will do or could do with Docker registries. And then in the example on the right, attackers, they will look for cloud platform credential, valid accounts, first step. Then they will modify the cloud infrastructure, for example, by creating big virtual machine with a lot of CPU, a lot of GPU, and they could do a resource hijacking, for example, to do crypto mining. That is not really efficient if you do that with your own money. However, specialists estimate that if you spend $1 mining crypto money on, for example, AWS, it's likely that you will earn in between 20 cents and 70. So for attackers, it's basically free money. Next, another thing of what we do besides thinking like attackers is trying to have a look at secrets with a big impact, and mainly secrets that are actually exploited by attackers. We describe them and we put them in 6 different categories. Obviously, container registries, like what we'll do today. But not only, we also have a look, and attackers, they look for these secrets for storage services, AWS S3 buckets, databases, cloud platform, to just, as we presented, directly go after your infrastructure and create a virtual machine. And as Git Guardian is doing for years, attackers is also looking for VCS, GitHub, GitLab, Bitbucket tokens in order to get source code and to get more secrets. So let's have a look at what needs to be done to scan a single Docker image. So basically, to interact with the Docker registry, we use the Docker command. So you build your image with a Docker file, and we'll have a look at that in the next slide. Then you push your image, you will upload your image to the registry. So this one is my name, gvaladon/secdays. So that will end up in the registry. And attackers, what will do, when they have the credential, they can Docker pull, which is downloading the image, and then start to scan for secrets. So that's the big picture of what attackers will do. So indeed, what needs to be done if you need to scan for a secret in a Docker image? So we'll go from a Docker file. So here on the left, we have 6 instructions: from, copy, run, expose, env, and cmd. The 3 ones on top in bold, there's instructions that will have a side effect on the final image. Final image is here in the middle, called manifest. From, copy, and run, we'll create what is called layers, which is a bunch of files, also called blob for binary large objects. And these layers are indeed tar archive, which are compressed. So in that example, we have 3 layers: from, copy, and run. Copy here, the name of the layer is SHA-256 FCBB27, and so on. The name is really specific. It's basically the hash of the content. So if you find 2 layers with same name, exact same name, means that the content is the same, which is some kind of optimization. If you don't want to scan a lot of similar layers, you can just check the name and scan only once. Later on, let's say on the weekend, if you want to play a little bit with Docker images and what's in Docker images, you can have a look at the Scopeo tool, which is a really convenient tool on the command line that helps you to get some specific layers, specific information. The Docker file here is inside the final image. It's a bit changed. It's not a flat Docker file, it's in JSON format, but the content is the same, and we'll have a look at that in this presentation and try to understand why secrets leaks are leaking in Dockerfile. And the layers and the config file, the Dockerfile in JSON, are then stored in a JSON manifest, which is the specific format of a Docker image. So to put everything together, a Docker image is built on your laptop or on your servers with the Docker build command and the Docker file, then push to the registry. The registry will contain a manifest which describes the layers that need to be retrieved, and the JSON config file, which is more or less the Docker file. So at the end of the day, scanning for secrets in Docker images means to scan JSON files and archives. You can scan for secrets manually if you have one image. Obviously, for 15 million images, it's not possible. And we have a tool for that at GitGarden, which is called GG Shield. You call it like that, GG Shield Secret Scan Docker, and the name of your image. GG Shield will get the layers, the config, scan for everything, scan for secrets, and give you the list of secrets it detected. So here in my image, I have a AWS key, which is invalid. That's a tool that you can download for free, test it, and you can install it on Mac, Windows, and Linux. So it's really efficient and the first step to scan for secrets in Docker images. One important aspect here is a validity check. My secret AWS key was invalid. And that's important to understand that when you find a secret, it's possible to test it from time to time. So in the case of AWS, we know AWS, that's an AWS secret. We know how to talk to AWS, so we can just test the secrets. So here, on the right side, we're the same with a GitHub token. And in most cases, scanning for validity is just connecting to an endpoint with a secret and checking for the HTTPS status code. On the right side, here we have the call to the api.github.com/user endpoint with a valid token in green. And we get back the 200 status code, which means the secret is valid. In the other hand, if we use an invalid token, we got the 4-1 result, which means the secret is invalid. So that's how we are able to check if a secret is valid or not, or if it can be exploited by an attacker or not. Scanning a Docker image is nice, but what we want to do next is scan a Docker registry and scan all of the images. So the methodology is quite simple. We start by enumerating repositories, then listing tags, retrieving manifests, and finally scan for config and layers and look for secrets. This methodology is nice and can be mapped to the Docker registry HTTP API. We have 4 endpoints that we'll use. First one is v2 catalog, and that is used to list all of the repositories in a registry. Then for each repository, you'll get the list of tags. Then using the tag and the repository name, you'll finally get the images manifests, and then using the manifest, you'll get the list of layers and the config file. So that's one of the first slides that I discussed today. And then you can start to scan for secrets. That's really simple. Scanning for DockerHub, so secrets in DockerHub is a bit different. So why? Because the catalog endpoint is not available, and that's a big issue because at first it seems that we have no way to get images. However, we are lucky because there is a web search in DockerHub that we can use to look for images and retrieve what we think is the maximum number of images in DockerHub. So what we'll do, we'll use keywords, specific keywords, and then retrieve the answer. There is a trick here that for a specific keyword like production, DockerHub will only return 10,000 results. So it's not possible to get more. So if you need more images, you need to use some trick. For example, you use production 1, production 2, production 3, and iterate until you receive less than 10,000 results per keyword. So this is a bit slow. It takes approximately 1 day to get all of the images, and that's the first result that we got. If you put everything together, we discover 26 million images, split in 9 million repositories, like gvaladon sec days. If you do some computation, you'll soon realize that it's a lot of data, 11 petabytes, and that's definitely something that is not possible to download or scan. So next, I will explain how we go from 11 petabytes to 50 terabytes. That's actually the data that we scanned, um, and uh, and that's where we actually detected secrets. The first fun fact of the day, that the most used name for repositories is Docker 101 tutorial, which means that people are actually using DockerHub to experiment with Docker images. Next stage, still trying to reduce the number of images to scan, layers to scan, is to have a look at tags. So here, that the picture showed that 93% of the repositories, they have less than 5 tags. And that's something that we think is safe to use in the sense that that will reduce the number of images to scan, but still capture 9 out of 10 final images in the dataset. So that's a nice improvement because we go from 11 petabyte to 6.5, but still too big. At that stage, we reduce number to 15 million images. And we have another result, which is the following. Latest is a tag that is widely the most used among images, which is a result that was expected because it's also the default convention when you name an image. Next, the idea is to have a look at the layers, and some of them are really, really big. Here, the first layer is 128 gigabytes. If you look carefully at what's inside, it's an image, a layer, sorry, containing machine learning models, which are really big and likely not containing secrets. So the next step here is actually to try to use the fact that Docker layer names are actually assigned that's the content. So if you already scan this layer, there is no need to scan it twice if it appears in several other images. The trick here is just to deduplicate. These small improvements, we go from 6 petabyte to 4.8. At that stage, that's 44 million unique layers. The biggest layer at the time of the experiment was 148 gigabytes. It's not the screenshot that I did before because this layer disappeared. So from time to time, the layer will appear, people will push layer in the DockerHub and later on delete them. And from time to time, secrets they will be in the layer at one point in time, they will stay valid after the layer is deleted. So that's why it's also important to do layer scanning of DockerHub. So next, we'll have a look at the instruction. So on the right side, we have the count, so run, accounts for 30% of all of the instructions in the dataset. And then we have env, copy, cmd, add, and the other ones like expose, work dir, and so on. The other interesting result on this slide is that on the volume side, run layers, they account for 3.3 petabytes in the final dataset. That's a lot of data. And looking carefully at these run layers, it's likely that they will not be super interesting when it comes to secrets, because most of these big layers, they are used to install software into the Docker image, like apt install something, apk add, and so on. So for this experiment, we decided not to have a look at run layers because we believe that it's not a big improvement regarding secret detection. However, what we are doing today, what we are doing in the product, we definitely have a look at these layers because they contain secrets. So here the focus is only on copy and add, and that's a nice improvement because the final number of data that we need to scan is 400 terabytes. It's still big, and we need to take one more step to decrease that number. And the thing that we did is to have a look at the layer sizes. This result is super interesting, means that 90% of the layers are below 45 megabytes. That's a huge, really, really interesting number. The other cool number is 99% of the layers are below 200 megabytes. However, for this experiment, we decided to keep the lower value of 45 megabytes. At the end of the day, we have 50 terabytes to download and scan. That's a lot, and that's also why we choose 45, because the final number is still big, possible to scan, but kind of really, really important. So if we put everything together, scanning for DockerHub, it takes approximately 15 days to do the discovery phase, listing the images, 26 million images, listing the tags, and so on. It takes 3 days to get to scan the config files. So here we scan 15 million images, which are basically the manifest and the config files. And it took 20 days to scan for layers. So we scan for 60 million unique layers, which means that it's likely that we have duplication between the images. And next, I want to present the results. So at GitGuardian, we have two different kind of secret detectors. We have specific and generic. So specific, they follow well-known patterns and formats, like the AWS key, GitHub token, or RSA private keys. They can be mapped to services and provider, so obviously AWS and GitHub. And sometimes they may be automatically validated. So GitHub, AWS, we can validate. RSA private key, it depends. Most of the time, it's difficult because we don't know, for example, in the case of SSH, we don't know the address of the SSH server. So specific secrets, that will be my focus today because it's possible to validate them. On the other hand, on the datasets, and most of the secrets that we found are generic, we have generic secrets. They are random looking. We don't know at first the name of the service provider, and they lack context. However, we are a bit lucky because at GitGuardian, we have a really great machine learning team, and they're able to put categories on these generic secrets. And on this data set, on DockerHub, they managed to put a category on 13% of the secrets, which is great because that's a big shift from unique, the generic to the specific secrets. Speaking of the classification, we'll have a look at two examples. The one on top, version control, that's a run command. And we have a secret which is hard-coded directly in the run command. And the machine learning model was able to tell us that is related to GitLab. It was not detected as such because the pattern is a bit different than a GitLab personal token. It's username and password. However, this is valid. And the great part is that because we know it's version control, because next another model will be able to tell us it's GitLab, it's then possible to try to check for the validity of this secret. The two other examples below for data storage are even more interesting if you don't know the services. ACE, that's the name used for SQL administrator for Microsoft SQL Server. So if you don't know that, there is no way that you will catch, and your brain will not catch that it's a secret for a database server. Next one is the same. If you don't know that Snowflake, that's a cloud-based database provider, you will never know that you are likely catching really interesting secrets related to data storage and databases. And again, because we are able to tell that it's data storage and Snowflake, it means that we'll be able to use our internal tools to scan for the validity of the Snowflake credential. So this machine learning model is really important and provides really great results. Moving on with the results. So here we found that 5% of the repositories that we scan contain a secret. That's a big number owing to the data set that we have. Next, here this is a kind of mixed. We don't know what to think of this. Basically, we don't know what to think of these results. So here, basically, the slide showed that most of the secrets are detected in layers, which might mean that we have here good Docker file hygiene, which means that developers, they do not actually hard-code secret in Docker file. On the other hand, because we scan way more secrets in layers than config, that's maybe why we have this split. And later on, we still have a look, because the main question here is, do developer hard-code secret in Dockerfile? And then in the last part of the talk, we'll have a look at that. And it's likely that this origin slide is not 100% accurate. Validity, again, in this talk, we are aiming at looking at secret as attackers. So the most important one is to have a look at valid secrets. 20% of the secrets in this dataset are valid, 1 out of 5. That's huge. That's 100,000 valid secrets. However, not all of them are really important for attackers. We have open weather map tokens in the datasets. These tokens can only be used to get the weather in cities like Paris, New York, and Tokyo, which is not really important for attackers. The result in orange is also really great, which means that 40% of the secret cannot be checked. For example, could be again private GitLab or GitHub instance that we know the secret for, but we cannot connect to the GitLab instance, which means that there is a big number of secrets that are really interesting for attackers. And if you look at these secrets manually, it's really possible that you will find secrets that are that have a really big impact. Types, so again, validity and the types. So here we try to map the secrets in the DockerHub dataset to the 6 secret types that we presented before. 28% are rated data storage, 20% are rated to cloud provider, and half of them are valid. That's a lot. That's most of our 100,000 secrets. They come from the cloud provider category. So that means that in DockerHub, there is secret that could be used to target companies, could be used to target organizations. Finally, the lifetime of secrets. So for me, that's the most important result. So here you can see that we detected a bit more than 35,000 secrets leaked in 2024, and that were still valid at the end of 2024. The other big result that 60% of the valid secrets that we detected were leaked before 2024. So in 2020, 2021, 2022, and 2023. In purple here, and for me that's the most important result of what we did, 2,000 valid secrets were leaked 5 years ago. They are still there, still valid, and some of them are really great impact on the company that they belong to. And they just have been forgotten. So this is not properly an analysis of the data that we collected. It's just a slide to answer a question: are we missing secrets if we don't scan the run layers? So my colleague, what he did, he had a look at all of the run layers. He looked for commands that might leak secrets, so git, curl, unzip, gcloud, arv, AWS. And then he manually selected 1,500 layers. So we scan them, and 20% they contain the secrets. So here, this number are not really important. The key takeaway message from this slide, that's run layers, they contain secrets. And here we have 2 examples. On top, that's secrets that are already in the config file. So that's a run layer. We have a password, which is hard-coded in the Docker file. And why we don't really, in that case, need to scan the run layer? That's because the git clone command, it will copy this password into the .git/config file. So if we just scan the config file, we'll get the secret, and we don't need to scan the layer for this really specific example. The next one is really great. Here we have AWS hard-coded secrets. This AWS hard-coded secrets in the Docker file is used to use the AWS S3 CP command to copy a file, which is .env, into the final layer. So here we definitely need to scan the layer in order to get the secret. So we get 2 secrets, the one from Docker file and the one from the layer. So let's move on to the next part, really close to the conclusion. Let's have a look at Docker pitfalls. So the first one that Docker remembers. So here on the left side, you have a Docker file with instructions. One of them, the first one, is trying to delete a file called npm.rc. That just not work. npm.rc is not removed in the final image, is still in the copy layer. So it means that if you get the layer, scan them, you'll get the file. If you execute, run the layer, if you try to look for npm.rc, it will not be there, but it will be in the layer. And that's the way Docker works. It will stack modification on top of each other. Next, big question that's reflecting on the chart that we have seen before. Is the chart correct? Are people leaking secrets in Docker file? So what we did, we had a look at a lot of the config files, which are more or less the Docker file. We use, for example, here the scopio command just to get what we need. We need get the config file dash config, and we find some patterns where people are actually hard coding secrets, like this one. We have echo username password into a file. But in practice, there are really few hard-coded secrets in Docker files. That's really weird because still at the same time we find secrets in Docker file, but people don't hard-code. So what is going on? So let's have a look at that. So as we said, there's some kind of change in between the Docker file and the final config file. So could it be a leak in configs? And that's a pattern that we really see often. A bunch of arg, which is like a variable name in the Docker file, and then env, which is an unknown variable. And we often see leaks in env. So what is going on? So in practice, it appears that the leak that appear in config as a result of Docker build. So it's a bit crazy. Let's have a look at an example. So here on top, we have a Docker file without any hard-coded secrets. And then below, we'll do Docker build. We'll use the --build -arg command to push a secret into the Docker build in order to use the secret at build time. However, what we can see below is that the secret is copied in the final config file, and it's appeared in arg and env. And it's a bit crazy. And when we discover that, we are like, okay, that's strange. It's bad. It's strange, but at the same time, I've been a developer for like 20 years. I know that I should not hard code. I know that I should use on variable. I know that I should, if not possible to use the variable, to use the arg on the command line. In that example, it's like I'm doing the good thing. However, the Docker documentation just states that build arguments and environment variables are inappropriate for passing secrets because they're exposed in the final image. So it's just there. There's a big warning sign. So instead, use secret or SSH mount. So that's what's here on the slide, the best practice. Same here on top, we have a Docker file. In blue, something a bit different. You need to use --mount type secrets in order to say, okay, let's use a secret from the outside world. Don't put it in the final config. Then in the Docker build command, you use --secrets and a specific secret configuration. And finally, here you can see that by using the mount secret, the secret are now leaked in the final config file. Takeaway message for today, something that we really want you to do in 2025 is to use and to include secret leaks as a key security threat. So why? Because you are probably leaking secrets. You don't know it yet. You are leaking maybe secrets in GitHub, GitLab, Slack, DockerHub. In the case of DockerHub, the secrets are there and the exposure appears because we have a wide range of Docker pitfalls. And from time to time, you think that it's safe, like with the arc parameter, but in the end, the secrets will leak. So please audit your Docker images for hard-coded secrets. We have tools for that. We have DigiShield if you want to scan a single image. We have the platform that you can use to scan for your everything in your Docker registry. So that will be my main takeaway message because prevention is indeed more cost-effective than dealing with a breach. So thank you for your time. If you have any question, let us know. I will be really happy to share more about this Docker research. We have a blog post describing that. So thank you. Thanks a lot for being there today, listening to me, and have a great event. Thank you.